So this lesson, 2.4, was actually added to the Algebra 2 curriculum because of what shows up on your SAT test. So this summer, the Algebra 2 teachers decided that we haven't seen this topic since like Algebra 1. It's been a few years. So the first bit of notes here, this is a review for you about what lines look like when you graph them. So remind me, when we have a horizontal function, a horizontal line, this is called a constant function. And an example of a constant function would be anything in the form y equals a number. So like y equals 2, or y equals 5, or y equals negative 1,000. All of those would be constant functions. What does the graph look like, though? It's going to be a horizontal line. So whatever that value is, it's going to be a horizontal line through that value. Very good. So the buddy to that would be your vertical lines. You have a vertical line. It represents all the places where the independent variable is always a specific number. Indent. You can't spell independent. All right. So it is the x value, yes. So they're in the form like x equals 2 or x equals negative 3. Whoops, that's a negative. Either way, what does the line look like, just in general? Up and down vertical line. Okay, so something like this. Now, bad news. All of our work today and tomorrow's lesson, it's going to be applications of linear functions. There's very few applications in the real world that produce vertical and horizontal lines. So our focus is going to be on the slanty lines, the normal lines that you guys are used to, which are known as transformations of the identity function. This is the identity function, but the line that you guys are most familiar with is this guy, y equals mx plus b. Sound familiar? This next form, though, this one might not be familiar to you. I'd like a show of hands once I write it down, and I want to see who has ever seen this other form before. It's called point slope, and it's y minus y1 equals m times x minus x1. Anyone ever seen that before in their past? Okay, cool. So, geometry? Or, oh, cool, great. That's wonderful news. Yay, geometry. All right, so slope. Which one of these variables represents slope? Yeah, m. Why is it m? I don't know. Because we're America and we call it m. We're the only country in the whole world that calls it m. A, or their equivalent to A in their alphabet. Because they go alphabetically. They go A, B, C, D, E, or whatever their equivalent is. Not us, though. We go m. All right, so the y-intercept. Which one of these variables in one of these equations represents the y-intercept? The b. The b. The other one doesn't have a y-intercept, and that's because sometimes we don't know the y-intercept in our clues. Sometimes we just have what's called a random ordered pair. So in real life, sometimes you don't know where you started, but you know some ordered pair. So notice in this point slope form, which is what this one's called, if you have a random ordered pair, you can place it straight into that question. Now notice what this question does, or this formula does have, though. It does have a slope. So today and tomorrow, here's the challenge. They're going to be word problems. And we know the thing about word problems with math is it's very rarely the math is the problem. It's the reading that's the problem. So you have to kind of interpret the question. They're never going to come out and say, hey, here's slope. You're supposed to know that they're talking about slope somehow. So here's some phrases that you're going to see when they're referring to slope. You're going to see things like average rate of change. You're going to see things like constant change. You might see some phrase that says like change in, and then something like change in height, change in money, change in time. So what do you notice is the same there? Change, change, change. So anytime you see a changing variable, that's associated with slope in these questions. And then the y-intercept, which is our b value, you're going to see phrases like starting point. Or you might see begins with. Or good old starts with. So they're never going to come out and say, hey, by the way, this is your y-intercept. You're supposed to know. And that's half the trouble. So, you guys already kind of answered this for me. But right here it says, sometimes your problems involve constant rate or speed, which is representative of your slope. And then it'll talk about a beginning amount, which is representative of your y-intercept. So they just want you to fill in those words right here, where m represents the slope and b represents the y-intercept. So here's what's great about math. There's not many things, but this is a good one. When they name something, they name it for what it is. So if you have a slope and a y-intercept, they want you to use slope-intercept form. That's what it's asking you to do. So this question, if you can find the clues, they are telling you slope and y-intercept. So let's start reading. We have an airplane that's 30,000 feet above the ground, and then it begins its descent at a rate of 2,000 feet per minute. And then it's going to continue on this trajectory, and then they want me to write an equation. So let's start with this clue about it being 30,000 feet above the ground. What is that? Like, as far as my linear equation goes, I told you we're looking for two things. I'm looking for slope and I'm looking for y-intercept. This is the y-intercept. This is where it starts. So you can call it b if you'd like, but it's the y-intercept. And then there's another clue. It says it begins descending at a rate of 2,000 feet per minute. What's that? Good, that is slope. What is the slope? Okay, 2,000 over 1 I heard? That is really, really wrong. Thank you for saying it, though. But thank you, because I was hoping someone would say that. Because all day, that's all the kids have given me, 2,000 over 1. So then I said, okay, so your plane is going a rise of 2,000 feet every minute. Oh my gosh, so not only do we have to read like implied things all of a sudden. The fact that it's descending. You're supposed to remember that that means negative. Now, when that shows up on your test, and it will, I bolded the word descending or underlined it or something, so hopefully that reminds you that it's negative. Sorry, that was really aggressive of me. Alright, so we have slope, we have y-intercept. We're able to write the equation, but not yet, because we got to figure out what the x and y represent. So I did like how you wrote the slope as a fraction. You says negative 2,000 over 1. And then the label here says feet per minute. Can y'all talk about slope for a minute? Slope is the change in y over the change in x. The label that's put on your slope from the problem is telling you what to call x and y. So right here, y is measuring the feet. Think about this problem, guys. What would you call it for the amount of feet that your plane is in the air? What's another way of saying that? No pilots out there? Altitude? Is that a word that you would use to represent how high up in the air your airplane is? So y, if you put number of feet that the plane is in the air, I totally know what you're saying, but like a human would just say it's the altitude. And then give me a label on that, please, feet. So in the denominator of this label, it's measuring change in minutes. So x is representing the number of minutes. So technically speaking, if you want to be real thorough, you'd say it's the number of minutes that the plane has been descending, because it's going to be in its descent for a while. Okay, you already talked to me about this, guys. What was the slope again? Negative 2,000 feet per minute. Notice I'm labeling our slope. And the y-intercept was 30,000. And then label it, please, feet. All right, we're ready to write the equation. I'm going to write it down here, though. I'm out of room. The equation says y equals slope. What was slope? Negative 2,000. And then we throw an x after that. And then plus our starting value. What was our y-intercept? 30,000. So there's your equation. And now what's good? What good is an equation if we're not going to use it? So take your equation and find the altitude of the plane after 5 minutes. So remember, minutes is the x value. So they want you to plug in x equals 5 into your equation. So this could be on your home screen of your calculator, or you can use the old noggin today. Negative 2,000 times 5. plus 30,000. What is that, 20,000 feet? And I know this was kind of like a lame example because planes don't fly linearly, so it's kind of a stupid example, but the idea is the same. If the control tower is trying to manage like all these airplanes and they're noticing that flight 413 is not at the proper place in their descent right now, they have to either adjust their flight plan or they have to get them back on track because they're going to overshoot or undershoot the runway or they're going to crash into another plane. So these are all things that they got to think about. Anyone interested in being an air traffic controller? That is an amazing job that pays a ton of money. You actually are forced to retire like in your way before retirement age because no, it's incredibly stressful. They make you retire before you're 40 with full benefits. No, not that. No, I'm talking about the people up in the tower. Oh, no. I mean, these probably pay lovely too. No, I'm talking the people up in the tower. If you are interested in that, it's an amazing job, by the way. Very stressful, though. Incredible amounts of math. So those of us who are like, I don't want to take a 4th year of math. No, big math in your future if that's your goal. All right, let's get one more done, guys. This one won't take us as long because we got the gist of this one. Okay, you receive $100 as a graduation present. What is that? That's our starting value, right? That's our y-intercept. And then because you're a super saver, you're going to put away $5 every week. What is that? That's your slope. So to give it a label, that's $5 per week. Keep that in mind. Identify the variables. Well, the slope label is what's going to help you with the variables, guys. Remember, slope is the change in y over the change in x. So x is measuring weeks, so I'm going to say that's the number of weeks. And then the y is measuring how much money you have. So what would be like a human way of saying how much money you have in your bank account? You can say amount of money in your bank account. That's fine. Is that called anything? Balance. Thank you. Some of us have negative balance, yes. No judgment. All right, so slope. This time, guys, you're adding to your bank account. So are they trying to be sneaky where I'm supposed to remember magically it's negative this time? No, this time it's just slope of $5 per week. The y-intercept started us off at $100. All right, time for an equation. So y equals $5 per week plus $100 to start off. Now be careful on this next question. I want to know when you're going to get $310 in your account because I'm going shopping. What variable is that? That's the y value. So you're going to plug 310 in for the y value this time and solve for x. Right, so super solving time. Ready? Subtract 100 from both sides. Get 210 equals 5x. Divide both sides by 5. And I think it's 42 weeks. Notice I keep labeling all my things that I'm finding. Very important in word problems, right? All right, we'll pick up here the next lesson.